Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology Peshawar. आज की जो मेरी वीडियो है that is about applied optimization. It's a third part of application of derivatives. We will be using a derivative for optimization problems. Optimization is basically it's a procedure, it's a process by which we find optimal values for a certain physical problem. If a physical problem is defined in mathematical form and then we want to find its maximum value or its minimum value, so such process is known as optimization. So we need to apply these optimization in some engineering problems. So what are the main steps to do to solve optimization problems? Okay, you will be given a theoretical problem, so you need to read the problem, you need to understand the problem, you need to draw a graph for the problem, or you may draw a picture of that problem, right? Then you have to introduce variables. Obviously we will be talking about a dependent variable, they are also termed as output variable. We may talk about input variables as well, so you need to establish the variables for that specific problem. Once you have done that, then you need to write an equation for the unknown quantity, that's for the output quantity. You need to define an equation which is obviously we may call that a function, which will be defining that physical phenomena, which will be representing that physical phenomena. अच्छा, फिर इसके बाद आपने अब इसको ऑप्टिमाइज करना है. You might be interested sometimes in minimum value, sometimes you might be interested in maximum value. तो उसको हम ऑप्टिमाइजेशन कहते हैं. तो जनरली वी मे यूज अ वर्ड ऑप्टिमल वैल्यू. तो ऑप्टिमल वैल्यू फाइंड करने के लिए हमें क्या करना होता है, हमें पहले तो डोमेन चाहिए कि वो प्रॉब्लम जो है वो कौन से डोमेन के लिए डिफाइंड है. वंस यू हैव दैट डोमेन, राइट, तो वी विल बी लुकिंग फॉर क्रिटिकल पॉइंट्स. वो पॉइंट्स जो कि स्टेशनरी पॉइंट्स हों या वो पॉइंट्स जहाँ पे फंक्शन की डिफरेंशियबिलिटी नहीं है, दे आर टर्म्ड एज क्रिटिकल पॉइंट्स. तो हमने क्रिटिकल पॉइंट्स फाइंड करने हैं और साथ में हमें जो डोमेन होगा, जो इंटरवल गिवन होगा, उसको हम क्या करेंगे, वहाँ पे वैल्यूज़ को फाइंड करेंगे और वहाँ से फिर हम डिसाइड करेंगे कि वेदर द फंक्शन हैज़ अ मिनिमम वैल्यू और अ मैक्सिमम वैल्यू. So let's talk about this example. Let's suppose we have a physical problem or engineering problem, that open box which need to be made by cutting small congruent parts in this. You see, if we have a square sheet, okay, and we need to cut a congruent squares here, and each square will be of length x, okay. And then what do? We simply bend up the sides. From here you will be bending this one upward, we will bend this one upward and this one upward and this one upward to get something like that. We'll be having a box, something like that. Now we have to make a box which basically have a maximum volume, okay. So what should be the dimension x in this case? What should be the value of x? Now we are given the total length is what? That is 12, right? Because the sheet is 12 by 12 inches. Okay, so let's suppose the box is cut with a square at each corner of length x. So this length will be, if you see this length, okay, this length, the part, this one, you see from here to here, that is 12 inches. This one is x inches and this one is also x inches. See, okay. So this length, the small, this part will be obviously total length is 12, so that will be 12 minus 2x. And similarly this part will also be 12 minus 2x. So we are having a box whose length is 12 minus 2x. Here you see that, whose width will be the same as 12 minus 2x, okay, this one, and the height of the box will be x. So we know that volume of a box can be defined as, that is simply equal to length, then width, and then height. So in this case, the length and width both are 12 minus 2x. So you'll be having 12 minus 2x squared, because we are multiplying the 2 times, so we may write, if you simplify, write in a simple way, so we could write that as 12 minus 2x. Okay, sorry, it's that there. So that is 12 minus 2x multiplied by 12 minus 2x. We just will get rid of this x square, and then multiply by the height, where height is what? That is x. So altogether we are having what? We are having a function like this: x into x 12 minus 2x whole square, which could be simplified ओपनिंग द स्क्वायर, और फिर उसके बाद उसके साथ हम x को मल्टीप्लाई करते हैं, तो ये जो फंक्शन बन जाएगा, ये बन जाएगा हमारे पास 144x, ओके, एंड minus 48x plus 4x cube, where x will be between 0 and 6. अच्छा, अब सवाल ये पैदा होता है कैसा क्यों है? इसमें अगर आप देखें तो हमारे पास जो लेंथ है वो टोटल लेंथ 12 है, और हम x को काट रहे हैं, तो ये पॉसिबल है कि हम यहाँ पर कोई स्क्वायर की लेंथ ना काटें, तो हमारे पास एज ए होल x की जो वैल्यू है वो 0 हो जाएगी। लेकिन अगर हम यहाँ से जितना काट रहे हैं तो उतना हम यहाँ से भी काटेंगे, तो मैक्सिमम से जो कटिंग हो सकती है, जो हम स्क्वायर काट सकते हैं, उसकी जो लेंथ है वो 6 हो सकती है। तो मैक्सिममली 6 हो सकती है, एंड ऑब्वियसली मिनिमम जो है वो क्या होगी, वो हमारे पास 0 होगी। अच्छा, अब नेक्स्ट स्टेप जो है, हमें क्रिटिकल पॉइंट्स फाइंड करने हैं, तो इसके लिए हमें वी डैश फाइंड करना होगा। तो वी डैश, दैट सिंपल डिफरेंशिएशन of this function v of x with respect to x, which is 144 minus 96x plus 12x square, and that will be taken equal to 0. So we have 144 minus 96x plus 12x square is equal to 0, which give you two values of x. One is 2 and the other one is 6, right? So we'll be finding now, once we have critical points, so the procedure is what? We find the values at the lower end, we find the value at the critical point, we find the value at the right end. Okay, so in this case we are having two critical points, one is 2, whereas the other one is 6. Okay, so it means, and 6 is also the end point as well, so we'll be finding only the values at 0. So you see, v of 0, that give you the volume will be 0, because we'll be constructing no box, so volume will be 0. And the next one is v of 6, which is the end point as well, and that will also give you volume to be 0. So we are having v of 0 is 0 and v of 6 is 0, so it means we need to find v2. v2, that is 2 multiplied by 12 minus 4, which is 8. So we'll be having 8 square, and that could be simplified to something 128. Okay, so we are having these values. v0 is 0, v2 is 128, and v6 is 0 as well. तो इन सब में जो मैक्सिमम वैल्यू है वो 128 है, जबकि मिनिमम वैल्यू 0 है। हमने इस प्रॉब्लम में इसको मैक्सिमाइज़ करना है। वी आर इंटरेस्टेड इन द मैक्सिमम वॉल्यूम। इसका मतलब ये है कि हमने v of 2 लेना है, एंड दैट v of 2 विल बी व्हाट, दैट विद द मैक्सिमम वैल्यू। सो द मैक्सिमम volume containing box will have a dimension for the cutting square x, that will be 2. अगर हम 2 इंचेस के स्क्वायर चारों तरफ से काट दें तो उससे जो बॉक्स बनेगा, उस बॉक्स की जो वॉल्यूम है वो मैक्सिमम होगी। ओके, सो लेट्स टॉक अबाउट अनदर एग्जांपल. Assume that you are asked to design a 1 liter can shaped like a right circular cylinder. What dimensions will use the least material? So if we talk about a cylinder, a circular cylinder, तो in that case हमें h को इन्वॉल्व करना है, उसकी हाइट कितनी होगी, और साथ में हमें देखना है कि उसका रेडियस कितना है। तो यहाँ पे जो पैरामीटर्स, जो वेरिएबल्स हैं, इंडिपेंडेंट वेरिएबल्स, वो एक हमारे पास हाइट होगा और दूसरा जो है उसका उसका रेडियस होगा, और जो डिपेंडेंट या जो आउटपुट वेरिएबल है वो क्या है, उसका वॉल्यूम है। तो हमने वॉल्यूम को 1 लीटर रखना है, इन दिस केस वॉल्यूम इज़ फिक्स्ड, और हमने इसको ऑप्टिमाइज़ करना है कि वो कितना मैक्सिमम वॉल्यूम को करेगा जिसमें हम मिनिमम मटेरियल को यूज़ कर लें, और वो केन जो है दैट ऑक्यूपाई या दैट कंटेन 1 liter of something. Okay, so you know that volume of a cane is defined as, that is pi r square h. Okay, where r is the radius of the of the cylinder or of the cane, and h is the height. Okay, now this volume is given, it is 1 liter, so it means 1 liters, which is 1000 centimeter cube. So we could write pi r square h is equal to 1000, and area of a cane or a cylinder, that will be 2 pi r square plus 2 pi r h. So this one, the first part, that is 2 pi r square, okay, this one, it is basically the upper part of the cane, which is a circle of a radius r. So area of this will be pi r square, and the same thing the bottom of the cane as well, which will be a circular. So in this case radius is r, so area will be pi r square, okay, as well. So we are having area of the top and bottom, that is 2 pi r square, whereas surface area of this part, you see, we are having circles, okay, like that. We are having circles like that, and every circle has a radius r, and the height of cane is h. So in that case we say the length of each circle is 2 pi r multiplied by the height would give you surface area. So total area, okay, that's the area function, it is 2 pi r square plus 2 pi r h. From this equation, you see, we can find the value of h, and putting that value of h here to get the equation I like. We know that pi r square h is equal to 1000. That gives you h is equal to 1000 by pi r square. Putting this value of h in above equation to get a, which only depends on r. ठीक है, तो यहाँ पे हमारे पास क्या आ जाएगा, a of r, that will become 2 pi r square plus 2 pi r, और h की वैल्यू लगा लेंगे 1000 by pi r square. When you do cancellation, we will be getting this function a of r is equal to 2 pi r square plus 2000 divided by r. अब हम इसके लिए मिनिमम मटेरियल को यूज़ करना है, लीस्ट मटेरियल को यूज़ करना है। इसका मतलब यह है कि हमने इसकी ऑप्टिमल वैल्यू फाइंड करनी है, ठीक है। ओके, तो इसके लिए हमें क्या करना है, फर्स्ट स्टेप इज नीड टू फाइंड डेरिवेटिव इक्वेटिंग टू 0 टू गेट द स्टेशनरी पॉइंट. So dA by dr, that is equal to 0, implies 4 pi r. 4 pi r is the derivative of this one, okay, and यहाँ पे आप सिंपल पावर अप्लाई करना है, so we get minus 2000 divided by r square, because r power -1 की डेरिवेटिव क्या हो जाएगी, -1 over r square हो जाएगा. And then solving this equation for r, if you just equate this one to 0, अब इसको इधर लेके आते हैं और फिर r square इधर मल्टीप्लाई हो जाएगा. So we get 4 pi r cube is equal to 2000. इसके बाद 4 pi से डिवाइड करेंगे, and then you simply take the cube root to get the value of r to be 5.42. और फिर ये 5.42 आपने यहाँ पे पुट करना है इस इक्वेशन में टू गेट द वैल्यू ऑफ h. यहाँ पे पुट करेंगे आप, तो यहाँ से हमारे पास h की जो वैल्यू है वो 10.48 आ जाएगी. इसका मतलब यह है कि इस फंक्शन की जो मैक्सिमम वैल्यू मिनिमम वैल्यू है, that will happen at the point r is equal to 5.42 and h equal to 1000 by pi into 5.42 square, which is 10.48. तो अगर हम ये डायमेंशन लेंगे, उस केस में जो केन बनेगा उसका वॉल्यूम तो 1 लीटर रहेगा, लेकिन इट विल बी यूजिंग अ मिनिमम मटेरियल. ओके, सो दैट्स व्हाट वी आर डूइंग हियर. सो इसी r की वैल्यू क्या होगी, 5.42 होगी. अच्छा, अब मैं कुछ क्वेश्चन सॉल्व करता हूँ फ्रॉम एक्सरसाइज 4.5, जिसमें यही हम ऑप्टिमाइजेशन प्रॉब्लम को ही डिस्कस करेंगे. So the first question of exercise 4.5 is saying, what is the smallest perimeter possible for a rectangle whose area is 16 inches square? ओके, एंड देन व्हाट आर द डायमेंशंस. सो हमें क्या चाहिए, हमें एक ऐसा रेक्टेंगल चाहिए जिसका एरिया 16 इंच स्क्वायर हो और उसके जो पेरीमीटर है वो स्मॉलेस्ट हो. तो वो क्या डायमेंशन होनी चाहिए, डायमेंशन मतलब उसकी लेंथ क्या होनी चाहिए, उसका विड्थ क्या होना चाहिए. सो लेट्स कंसीडर दिस इज आवर ट्राइंगल, रेक्टेंगल सॉरी, जिसमें हमने एक को उसकी लेंथ को है x कहा, उसके विड्थ को हमने y कहा. ओके, तो इसका जो एरिया बनेगा दैट वुड बी x मल्टीप्लाई बाय y. Okay, so area in this case is given by, we know area of a rectangle is simply length multiplied by width, and that area is given to be 16 inches square. From here we may find the value of y. So y is equal to 16 divided by x. Okay, now we are interested to talk about the circumference perimeter. So perimeter, which is p of x, is simply the length of, in fact p, that is equal to perimeter, that is 2 times x plus y. Now we may put the value of y here to get 2 into x plus 16 by x. So now we are having a function of x, that perimeter, the p of x is equal to 2 into x plus 16 by x. Okay, so now we need to find the critical points. For that we need to differentiate the given function. So we will take p dash x. So p dash, that will be simply 2 into 1 plus, in fact minus 16 divided by x square, and we equate that to 0. So that means 16 by x square is equal to 1, and that would give you x square is equal to 16, which give you x equal to 4. So if x is 4, what about y? Where y is equal to 16 by x. Okay, that's so y is equal to 16 divided by x, where x is found is 4. So we simply have 16 divided by 4. So y should be 4 as well. ठीक है, इसका मतलब ये हुआ कि हमारे पास अगर किसी रेक्टेंगुलर शेप का एरिया 16 इंच स्क्वायर है, ठीक है, तो उसकी पेरीमीटर स्मॉलेस्ट होगी अगर हमारे पास स्क्वायर होगा, यानी x और y दोनों क्या होंगे, 4 के बराबर हो, तो एरिया 16 होगा और उसके बाद उसका जो पेरीमीटर है वो मिनिमम रहेगा. Okay, show that among all rectangles with an 8-meter perimeter, the one with the largest area is a square. In this case, we are doing for the other way around. We are given the perimeter, which is 8 meter, and we need to maximize the area. So again, the concept is same. What would we do? We would simply take the value of perimeter now. So P equals 2 times x plus y. Okay, now P is what? It is given in this case, that is 8 meters. So 8 is equal to x, 2 into x plus y, which basically means x plus y equals 4. और यहाँ से हम फिर y की वैल्यू फाइंड कर सकते हैं. So y is equal to 4 minus x. अब area of a rectangle is what? If you call that A, so it is simply the product of length and width. It's length multiplied by width. Now x and what is y? That is 4 minus x, which could be simplified as 4x minus x square. Now to find the optimal value, we need to maximize it. So for that purpose, what would we do? We differentiate the given function. So dA by dx, which will give you 4 minus 2x, and that will give you what? Equal to 0, because we have to find a stationary point, and that would give you x is equal to x is equal to 2. One. Come on, where is gone? Basically closing. Anyway, so that is x is equal to 4 in this case. 4 minus 2x equal to 0, that gives you x equal to 2. Now if x is 2, what about y? We see that y is equal to 4 minus x, and putting the value of x, which is equal to 2, so we have 4 minus 2, that is equal to 2 as well. So x is 2 and y equal to 2, x is equal to y equal to 2. तो अगर किसी भी रेक्टेंगल में लेंथ और विड्थ दोनों बराबर हैं और 2 के बराबर है तो वो स्क्वायर होगा, और यही हमने प्रूफ करना था कि एनी रेक्टेंगल विद 8 पैरामीटर एंड हैविंग लार्जेस्ट एरिया दैट मस्ट बी अ स्क्वायर. Okay, that's what we have done already. So you see the same example, right? So the next example is what it says: a rectangle has its base on the x-axis and its upper two vertices on the parabola y is equal to 12 minus x square. What is the largest area the rectangle can have, and what are the dimension? Okay, so we consider this graph of 12 minus x square, right? We can see that. एंड अब इसमें हम क्या करते हैं, एक रेक्टेंगल को कंस्ट्रक्ट करेंगे. ठीक है, यहाँ से ये लेंथ हम ले लेते हैं. ये लेंथ किसके बराबर होगा? अगर ये पॉइंट हमने यहाँ से लेकर यहाँ तक x के बराबर लिया हुआ है, यू सी यहाँ से ये जो पॉइंट है फ्रॉम ओरिजिन टू this point, it is x. So this point will be what? That point lies on the curve y is equal to 12 minus x. So this point will be obviously 12 minus x square. So the height of this will be what? 12 minus x square. The same thing is here. If this is x from here to here, so we also have x from here to here, and this length will also be 12 minus x square. ठीक है, तो यहाँ से लेकर यहाँ तक जो लेंथ है वो 2x हो जाएगा, बिकॉज x प्लस x दैट इज 2x. Okay, so once we have that length and that height, so area of the rectangle will be, area is what? That is length multiplied by the width. So length is 2x because it's x plus x, that is 2x, whereas width has been found to be 12 minus x square. That's the area, because we are interested in the area function and we have to maximize the area. So that is 2x into 12 minus x square, which could be simplified as 24x minus 2x cube. अच्छा, अब इसको डिफरेंशिएट करना है हमने. So I may consider just a dash, which will be 24 minus 6x square, and equate that to 0 to get the critical point, a stationary point, which may be simplified to, this means x square is equal to 4, and from here we simply find x is equal to 2. Okay, so the dimension would be what? That is 2, the value of x. And what about the maximum area? The area will be simply found. The maximum area is a, that is equal to 2 into 2 multiplied by 12 minus 2 square. So that is equal to 4 multiplied by 12 minus 4 is 8. So area will be 32 inches square, or whatever जो भी उसमें है, that is 32. That's the area of the rectangle, which will be maximum area. Okay, जी, you are planning to close off a corner of the first quadrant with a line segment 20 units long running from A0 point to 0B point. A0 is a point on x-axis where 0B will be a point on y-axis. Show that the area of a triangle enclosed by the segment is largest when A is equal to B. In this case, we consider x-axis and y-axis because we have the point, the line with the length of 20 units in the first quadrant. So you see, we have considered these points. So the first point is on x-axis. Okay, we can go to this point. See here, this point is what? That is A and 0, whereas this point is what? That is 0B, whereas this length is given to be 20, and this is A, whereas this is B. Now we are interested to have the area to be maximum. What about area of a right angle triangle? We know that area can be defined as area of a triangle, that is half base into altitude. In this case, base is what? That is half into A multiplied by B. Okay, so area function is what? That is half AB, whereas we are also given that length of this is 20 and it's a right angle triangle, so we should have A square plus B square is equal to 400 by using Pythagoras law. Okay, it's a Pythagoras law. Right, so from here what do? We can simply find the value of B, जिसको हम लिख सकते हैं कि B is equal to square root of 400 minus A square. That's the value of B. Right, अब ये जो वैल्यू है ये पुट करना है हमने फंक्शन में, so which will be depending on A then only. So that's a function of A which will give you 1 by 2A and then the value of B. Right, so for optimal value we need to have a derivative to be 0. So phi dash A, that is equal to 0, and I hope everybody knows how to find the derivative. So it's simply 1 by 2, product rule apply करना है, 1 by 2 400 minus A, and then we have minus 1 by 2A, and applying power rule on this one to get minus 1 divided by 2 under root 400 minus A square, and then you simplify this to get the value of A. Right, so in this case obviously the value of A and B, they would be same. Right, so it's simple now to simplify this equation. Okay, let's talk about the seventh question. It says a rectangular plot of farmland will be bounded on one side by a river and on the other 3 sides by a single strained electric fence. With 800 meter of wire at your disposal, what is the largest area you can enclose? And again, what are the dimensions? So let's suppose that's the river side of the farmland, right? And the remaining 3 sides, they will be closed with what? With the fence, right? So we assume this. We assume that these 2 lengths are same. So this would be, let's suppose, x. This will be x, and this will be, let's suppose, y. Okay, so we are given what? The length is what? That is 800. So it means in this case, length is what? That's the perimeter. So perimeter of that, by using that fence, it will be 800, which means 2x plus y equals 800, which can be simplified for y. That will give you y equals 800 minus 2x. Now area of this will be what? Area of this farmland is simply length into width, so it will be x multiplied by y. Y is already found to be 800 minus 2x, which might be simplified as 800x minus 2x square. Now to find the critical point, we need to differentiate this function. So a dash, it will be 800 minus 4x. Equate that to 0, which will give you x is equal to 200. Okay, so if x is 200, what about y? Y is y is y is 800 minus 2x. Okay, so y is come on, y is 200 800 minus 2x. So that means 400, because 800 minus 800 minus 2 multiplied by 200, which give you 400. So that will be 400. So we need to take this length to be 400. This should be 400 y, and these two should be 200 and 200, and area in this case will be simply 200 multiplied by 400. That will be square units. So it will be the area, that's the maximum area in this case, that's the largest area you can have, and the dimensions are what? X length is 400, whereas the width will be 200. Okay, let's talk about question number 8. A 216 meter square a rectangular pea patch is to be enclosed by a fence and divided into two equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence, and how much fence will be needed then? Okay, so again we have a rectangular pea patch which has an area of 216. We are having another line which is dividing this rectangular pea patch into two parts of equal parts, obviously. So what do? We take this one as y, this one will also be y, whereas this part is x, this is also x. The same thing in the lower part as well. Now you see, we are given that area is what? That is 216. So in this case, if area is 216, area of this rectangle will be x plus x, that's the length, multiplied by y equals 216 meters squared. And then we can simplify and value of y from here. So y is equal to 216 divided by 2x, or we may have y is equal to 108 divided by x. That's the value of y. Okay, now we are interested to find the value of the optimal value of a parameter. So parameter in this case will be what? It will be, parameter is x, 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 y plus y. We may have 4x plus 2y. Now putting the value of y, we get p is equal to 4x plus 2 into 108 divided by x. Okay, so that will give you 4x plus 216 divided by x. Now we have to differentiate this to get the maximum value, to maximize the smallest total length. So we have to minimize this one. So how could we do? We simplify the derivative. So we take p dash and equate that to 0. So you know derivative of 4x is 4, and then we have minus here. So we will be having minus 216 divided by x square is equal to 0. And from here then you can simply find the value of x, because you will say 4 is equal to 216 divided by x square, or 4x square is equal to 216, and then you can simply find the value of x, and then you can find the value of y as well. So thank you very much, and see you in next video. Okay, so you may share this video with your friends, class fellows, classmates, or बैच फेलोज़, ताकि उनको भी इसका थोड़ा सा फ़ायदा मिल जाए. Thank you very much and see you again.